I am Alejandro Velasquez, a first-year student in PhD in robotics at OSU, and I will be talking about learning to pick apples using an apple proxy. This is important for us as apples are among America's most consumed fruits and are very labor-intensive to harvest. Its harvesting shares some similarities with other fruits, such as the stem location. Despite of all the work that we have seen, none of it have performed using a physical proxy. And for our long term, we want to use machine learning and this physical proxy to train robots how to pick apples. We want to appropriately pick an apple without bruising the fruit or the tree and within a relative small amount of time. This is hard because these are unstructured environments. Apple pick success depends on occluded features, and also there are big amounts of data. It should reach a reasonable throughput compared to humans. The approach we had was designing this apple proxy that consists of 3 subsystems. First subsystem is an apple. Second one is the stem. You can see that the stem has 3 rotational degrees of freedom, 1 linear one, and the apple can get detached from it very easy. We have a third subsystem, which is the branch that has some bushings, and the bushings consist of a polyhedron of 15 faces, where up to 15 stems and apples can be attached to it with different orientations, and the whole assembly can be moved in order to mimic different sources of movement. We used a robotic manipulator, a robotic 2F85 gripper, and did 3 different initial ideal poses, 90, 60, and 45 degrees, and for each one of these we added some noise. This is how the first successful picks look like. You can see that the net force reached a value up to 30 Newton, which is very close to what we wanted it to be. But we were also interested not only in the successful picks but also in the failure ones. So this is a first failure. It occurred as the gripper was approaching the apple, and due to the noise the gripper jumped into it, and that's why you see a negative force, which is actually telling that the wrist was under a certain compression force. There was also failures occurring when the gripper slipped from the apple as it was trying to pull it from the stem, and you can tell that the value was very low from the 30 Newton threshold, and also that the force in the y-axis was very low as well. This is a third case where the failure occurred as well with a slippage of the gripper with respect to the apple, and also the apple kept touching the gripper at the end, right there. So that's why you see all these force profiles after the grippers slipped. So as a summary of our results and our plots, we have the top row with the successful picks. You can see that most of them occurred at a net force with a value close to 30 newtons, and all of them are very similar in quantitatively and qualitatively, whereas the bottom row represents all the unsuccessful picks, where you see the 3 cases that we have discussed in the previous slides. Also, here we can see a more quantitative information about the values where the successful picks occurred at. Most of them occurred at a value of 30 newtons, whereas the failure ones occurred at different values, but some of them occurred also at 30 newtons, which is why we have to use not only the quantitative information but also the qualitative information. Finally, these force profiles showed a similar behavior to the one obtained by one of our references with real apple trees, despite of the fact that we used a simple gripper. These force measurements are promising to compare the successful and unsuccessful picks. We would like to thank our supporters and also to you to listen to us. Thank you.